Hi guys, today let us do the revision of the second module. Well, here we studied about the concept of equilibrium of concurrent and non-concurrent forces. Well, equilibrium is nothing but a system of forces acting on a body in which the resultant of all the forces is 0 and the algebraic sum of the moments of all the forces is also 0. Hence, we get summation h is equal to 0, summation v is equal to 0 and summation m is equal to 0. Next, we studied about the different principles of the equilibrium, that is, the two-force system in which a body acted upon by two forces will be in equilibrium if the forces are equal in magnitude and opposite in direction and also collinear. Then the three-force system in which a body is acted upon by three forces is said to be in equilibrium if the resultant of any two forces will be equal, opposite and collinear with the third force. And then the four-force system in which a body is acted upon by four forces is said to be in equilibrium if the resultant of any two forces will be equal and opposite and also collinear with the resultant of the remaining two forces. Then we studied what is an equilibriant, that is nothing but a force which is added to a concurrent system that will be equal in magnitude, opposite the direction and collinear with the resultant force and hence will bring the body to the state of equilibrium. Then we studied and derived the Lami's theorem, which states that if three coplanar forces are acting simultaneously at a point which is in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Hence, we got P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. Then, using this principle and the basic concept, we solved the numericals related to the equilibrium of forces. Then, we moved on to the concept of friction. Well, friction is nothing but the resistance which is offered to the movement of one body which tends to move in contact over the other body. Then we studied the different types of frictional forces, that is, static friction which acts on a body which is at rest, limiting friction which is the frictional force acting on a body which is just on the point of sliding, dynamical friction which is the friction acting on a body which is in motion, dry friction, that is the friction acting on a body when the contact surfaces are dry, in which it is further classified into solid friction and rolling friction, fluid friction, in which the friction acting on a body when the contact surfaces are lubricated, that is further classified into greasy or non-viscous friction and viscous or film friction. Then we came to know that angle of friction is nothing but the angle with which the resultant reaction due to the normal reaction and frictional force makes with the normal to the surface, that is tan phi is given as F by R. Next, the coefficient of friction is nothing but the ratio of the limiting friction to the normal reaction between two surfaces, that is mu is equal to F by R. We also came to know that this is equal to the tangent of the angle of friction and hence will be equal to tan phi. Then we came to know that the angle of repose is nothing but the angle at which an inclined body is just on the point of sliding down. Hence, this angle of repose is nothing but the angle of limiting friction. Then we studied about the laws of dry friction, that is, the frictional force always acts in the direction opposite to which the body tends to move. The magnitude of limiting friction bears a constant ratio to the normal reaction between two surfaces, that is, the coefficient of friction mu is equal to F by R. The magnitude of the forces of friction is exactly equal to the force with which it tends the body to move as long as the body is at rest, that is, P is equal to F. The force of friction is independent of the area of contact between the two surfaces, and the force of friction depends upon the roughness of the surface in contact. Then we solved various problems on friction, such as frictional problems on a horizontal plane, frictional problems on inclined planes, problems on wedge friction, and problems on ladder friction. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.